That's how you avoid overfitting. Now, it turns out that information gain, it's a good measure, but it has some flaws that you need to address, right? So suppose, remember in our data set, we also had day as one of the attributes. So what would happen if we split on a day? If you split on a day, there were 14 days in the training set. So we would end up with 14 singletons, right? And each one of those singletons would be by definition pure, right? So why is it pure? Because on each day, John either played or didn't play, right? So each one of those is going to be either positive or negative. Right? So, and that presents a bit of a problem, right? Because as far as information gain is concerned, this is a really good attribute to split on. You pick one attribute and magically, wham, in one split, all of your subsets are pure. So as far as information gain is concerned, this is it. This is the holy grail. This is the killer feature. This is the attribute that solves the problem in one swipe. The problem is, of course, it's not terribly useful because what do you do with day 15? Right? That's not a part of the tree. You don't have a branch for day 15. And in general, so this is happening because we're keeping the day number as part of our attributes, but it will happen in general. You will have some attributes that have lots and lots of values, and they lead to tiny, tiny little subsets, and those tiny subsets will probably be pretty pure. And gain will try to latch on to those attributes and put them at the high nodes, at the high levels in the tree, and they generalize poorly to the testing data because they're not very useful. So one way to get around this is to use gain ratio. So what you're going to do is you're going to take your information gain for the attribute and then normalize it by something called the split entropy. And what the split entropy is, it's basically a way to quantify how tiny, does this attribute give me lots of tiny subsets or not. So split entropy, it's just the entropy of the split itself, without considering the positives and the negatives. It looks at it'll have high values if you end up with lots of tiny subsets, and it'll have low values if you end up with few big subsets of the data. So gain ratio tries to normalize the mutual information, the information gain, by how fine-grained the split is. So that's a good, if you have attributes that end up to tiny fractures, that lead to tiny fracturing of the data, gain ratio is a good thing to use instead of just the normal information gain.